makers over there, over here, over here. So there's quite a few. So it's a tough crowd. Okay, so when we think of waterproofing can mean a lot of different things in terms of the terminology. It can be the membrane, it can be the system, it can mean a whole bunch of things. And really the message I really want to start with is it's a lot more than the membrane. So how can water get into a structure? There's lots of different things that we need to think about where water can come from and how it can get through. Now the blue lines are supposed to be water, and it can get through the structure. The substrate itself can have defects, cracking or honeycombing, for example. And you've got different types of substrates as well that we need to think about. Some substrates are actually waterproof, that may not need waterproofing, and they might be right connected next to something that does. And that leads us to joints. The arrows are meant to represent a joint that can contract and expand. We've got different materials, you've got different greys, shades of grey there. Not everything is necessarily uniform. How does that interact with each other? We've got pipes coming through, we've got things that we're embedding in the slab. There's a lot of different things to think about. And if you look at, there's also a chance for me to experiment with drawing things on PowerPoint. So the yellow is meant to be all of the waterproofing treatments. So with substrate, we can do repair mortars, we can do injections, we can do admixtures as well. You see the little dots on the bottom, that's meant to be an admixture there. The membranes, of course, can address the substrate, water ingress. We've got the joints, sealants, water stops, etc., etc. Look, if you're not a waterproofing specialist or expert, you don't have to remember all this. What I'm really trying to communicate is that it's a lot more than just a membrane system that needs to be considered and thought of. And so what is a waterproofing system? Here's a few definitions here from the NCC and the standards. And you can see in these definitions, they're acknowledging that it's a lot more than just a membrane. It includes the substrate, the membrane, the bond breakers, the sealants, the finishes, and the like. So it's very open there in the NCC. It can be a lot of things. And in the standard 4654 Part 1, for those of you who don't know, that standard is 4654 is about external membranes above ground. And it talks again about primers, mechanical fasteners, waste outlets, flashings, membranes. I've highlighted that, they're my highlights in red, not necessarily in the as written. And we've got the internal standard, which also talks about a combination of things: substrate, membrane, bond breakers, water stop, sealants, and finishes. Now, they're all got slightly different components of the system, but I would say they're all equally applicable could be applicable in all those situations. So we're trying to hopefully get the idea now that it's not just about membranes. And here's just a random picture of a structure. There's a lot of water ingress opportunities on a structure, whether it's a below ground area, a balcony, a terrace, a podium, the internal wet areas, a roof. And how are we going to address all of these things? And we certainly have heard about some cases that it's gone wrong, and we all know that there's a lot of defects out there as well. So to select a waterproofing system, I've put together a list of things, and look, these are all big topics on their own right, and I'm not going to attempt to go through all of those today. But what I really want to talk about now is the evidence of suitability, performance, and compliance. And this is where hopefully there's my hero piece of information that even the experts would not have seen, and I hopefully provide some insight. So how do we demonstrate compliance with the NCC 2022 when it comes to membranes? For volume 1, class 2 to 10, 2 to 9, we've got material standard 4654 Part 1. And then we design it with Part 2, which is something we saw pop up in one of the earlier cases today. And then when it comes to housing, it refers to 4858, which is the internal material standard for wet areas. basically both of these standards will apply. I've just pulled out the particular ones where it's referencing the standard specifically. Now this is where I'm trying to, I guess, pull through something that I think is not really given enough attention, and that is how do we prove the suitability against the standards with these with the membranes, because it really is only the membranes that we have this evidence for routinely, but we've also discussed that there's a lot of other components as well. So the most common forms of evidence that we see in the industry are a code mark certificate of conformity. Again, I've bolded the bits that I think are the most relevant here. It's not how it's written. And then the other method is a report by an accredited testing laboratory. So that testing laboratory is NATA registered or has some sort of mutual recognition with NATA. And it sets out what those tests should be to fulfill the requirements. So this is what you might get if you ask for a evidence of suitability from a supplier. So the first one, that's only one page of about 7 in this particular report. It has a certificate of conformity from CodeMark. So to get CodeMark, you need to have everything tested. That's used as part of the assessment process. They visit the factory where the products are made, and there's an annual QA audit. So it's actually quite thorough. To go through that process of testing and to get the certificate, that costs a manufacturer about $30,000, especially if they're going to, some products are suitable for internal and external use, so they're being tested to 2 standards, so that can cost around $30,000. When it comes to the test reports, it's a little bit different. It's not sort of saying it's compliant to NCC, it's saying that it meets the standards which then comply to the NCC. So we've got the front page, and you've got a few logos there of a few testing, not authorities, but testing laboratories or ATLs, and they'll go through the standard and test everything, and that's what you get. So that process is $10,000 to $20,000. So the interesting thing, okay, not the hero slide yet, that's the one after this. So just a little bit about that testing. You may have heard of different classes of membranes. What they do to determine that class is that they put a sample of the membrane, a dry sample, under elongation or under tensile testing. And depending on how far it stretches before it breaks, that will determine the class. So class 1 has the most extension, greater than 300%, has the most flexibility. And then you go down to class 1 that has the least flexibility. It will break much sooner when you put it under tensile load. The standard looks at moisture vapor testing, water absorption testing, the durability. For example, bleach and other chemicals are, the membrane is exposed to that to see how it reacts. And then for the external standard, you've got resistance to UV, you've got resistance to abrasion, root damage, and so these are the 2 material standards, just to keep up with that. Now this is really where I want to pause, because this is the information that is something you may not have seen before. As part of the last 6 months, I've been going through a lot of manufacturer information, code mark certificates, test reports, data sheets, and looked at the 16 different manufacturers and looked at 150 or plus products. Now, I'm double counting some products because some are suitable for internal and external, but I've gone through all those standards and I've looked at the information and tried to understand, have they demonstrated that the evidence of suitability as required? And one side is the internal membranes and the other one is external. And funnily enough, the numbers actually came out about the same. So roughly 30% of all of the test certificates that I've seen actually don't necessarily comply with the evidence of suitability. I'll tell you why coming up. But that to me is quite shocking because I've just told you how expensive it is to test one product. Most manufacturers have multiple products. Some have a huge range of products. So not only have they put money into testing or compliance certificates that may not be going to give them any return, if they're submitting it to a project and it gets rejected, the loss of sales is actually going to be considerably more. So it's a really important thing, I think, for suppliers, for consultants, for builders, anyone who works with this information or has, every project has waterproofing on it, really understanding what you're looking at. So I'll tell you why the 30% occurred. Funnily enough, you'd be surprised how often the product name on the test report and the data sheet are completely different. It's staggering, but is one of the most common reasons why it doesn't comply. A test report either will be given, oh, it's kind of the same, we've changed the name, or they've actually overlooked in their due diligence when they review the test before they actually pay for it. They usually get a draft copy to check it, and they've not picked up in their due diligence. It's P43 instead of P46 or things like that. So that's one of the most common reasons. So how can it be taken as a test report as evidence if it's not even the same product name? The test report has passed the expiry date. Most of the test reports you'll see on the front page, on the bottom right, will have an expiry date. So it's usually 3 years or 3 to 5 years that test report will expire. And often, and especially if you've got many products, if you're not on top of managing the retesting process, which can take about 6 months or so, sometimes more depending on demand, if you don't stay on top of that, you're submitting a test report that's out of date before the project's even started. I've even seen things on data sheets where they're claiming compliance, but we've already submitted it for testing. It'll pass, it'll be fine, but it's already on the data sheet. So that's kind of interesting. This is another really common reason that the reports don't align. So dry film thickness, especially for a liquid membrane, because with a sheet membrane, it is something that is fixed in the factory. It's made to a certain tolerance. But the liquid applied, and let's face it, that is a majority of what gets applied out there. Some, not all, suppliers might put a lower film thickness on their data sheet so that when someone goes to calculate the applied costs and comparing products, theirs will look pretty good because they don't need as much material. So they try and put the minimum that they can get away with in terms of performance on the data sheet. But when it comes to testing, what they test might actually be a lot higher thickness. And so there's some suppliers which have been very good and diligently make sure that their data sheet aligns with their test reports, but I've got to say right now that's the minority. So usually what they've tested is higher. Now with thickness of membranes, the thicker it is generally, it's going to be a bit more robust. It's going to, if it's thin, if you think of it, imagine a rubber band or something like that, and you stretch it, those really thin ones are probably going to break before something that's a little bit more substantial. So think about, what does that mean? So it's got the right name, looks like the right product, but is it what I'm actually going to apply? Is all the data on the data sheet going to align with what's in the test report? Usually it won't. Okay, the dry film thickness of the membrane tested is omitted on the test report. Now, this is a more recent thing. There's a couple of the ATLs who are not putting the thickness on the test report. And I've even seen a copy of an email from one of these labs back to a supplier which says, we don't need to do that, which makes no sense at all, because what we're trying to do is verify that the product that is on the data sheet is the same as what's tested, and we can know what class it is and how to treat it. And without that information, it's very, very, it's a waste of money, basically. So I have the opinion that the manufacturers are paying for these tests. They should insist it's on there. And I think that's partially an education process as well. But it's certainly, I think that's mandatory. Okay, the next one is the membrane. So both in the internal material standard and the external material standard, there is a requirement that if reinforcement is used as a standard part of the system, that you should be doing the testing with that included. Now, don't think that really any of the ones that I've seen to date where reinforcement is on the data sheet has actually been tested, or at least it hasn't been clearly stated on those test reports. And there's a lot of materials that don't need reinforcement, but there's still some manufacturers that is their practice and they're not testing with that reinforcement. So if it is something that is optional, depending on a certain situation, then you're going to need to test both, because the materials will behave differently. If you've got a reinforcement fabric inside a liquid membrane, they're going to behave differently. So that's one other common thing that I've seen. And interestingly, so membranes that are designed to be exposed, so these are things where they don't have tiles or pavers or buried or, things like that. They're going to be exposed. So if you think about it, when it's exposed, someone can walk on it. It's going to be exposed to UV. So interestingly, there's data sheets that will say that the product is suitable to be exposed, but it hasn't been tested for UV, it hasn't been tested for traffic, and you think you've got a whole report, but then you sort of do that double take and go, hang on, how can you say that when you actually haven't even tested it? I've got to say though that the UV testing that we have in the standard it's called a QUV test, which is an accelerated UV aging exposure test. It has a requirement of 1,000 hours. In Sydney, I Googled it, our average daylight hours is 2.5 times that for 1 year. So it's not very stringent, but some of them aren't even testing that. And the same with the foot, whether it's foot traffic, whether it's regular pedestrian traffic, whether it's vehicle traffic. There's an abrasion test in there which determines what membrane is suitable for which of those traffic types. And those tests are either not there, or there's a conflict between what the data sheet says and what the test report says. And sometimes the data sheet is claiming a higher level of traffic resistance than what the testing backs up. Okay, so planter boxes. So that's another one where it's a claim that it's suitable for planter boxes, but it hasn't been tested or have any evidence of root resistance. And that is a key requirement for planter box membranes, or could be landscaping as well, depending on the planting. But that is definitely a requirement that's very clear in AS 4654 Part 2. Okay, the test report, as I've said, there's a conflict of information between the data sheet and vice versa. So the classes could be different. The type of use could be, an application can be different. It could be any test on that report, if that data conflicts, I just think that you can't accept that, because which one, really, to me, the independent third-party test report would be what I would look at as being verified over what's on a data sheet. But a data sheet is the primary source of information for any product. And just on that note, and I know if you do expert witness work, I'm not sure if you do know, but data sheets should be version controlled. So if there was something that was done 4 years ago, you should be able to go to a manufacturer, whether they give it to you or not, I don't know, but they should have a copy of the data sheet and all the changes that have happened over time. So they should be maintaining the version of the data sheets. So that's a little side note there. Next, the data sheet claims that there's compliance, like the one I said earlier. We've sent it off to testing. So we've put it on our data sheet knowing that it's going to come back and it's all going to be fine. And I definitely know of products that's the case. Or even things like we saw in the last few years since the DBP's come in, designed to comply to AS, blah, blah, blah. That's not the same thing. And the data sheet can also, there's a lot of data sheets of a lot of products on the market that have never been tested. There's no intention of testing it. And funnily enough, in New South Wales, we're the only state that really asks for these reports a majority of the time. So these standards we've had since 2009, the current sort of standards kicked off, and I was working in this space at that time, telling my bosses, we need to get this tested. How can I say this complies when we don't even know? And it wasn't really until many, many years later, and really the DBP came in, that made manufacturers actually go out and get this testing done. And it's a big investment. And not only are you trying to assure compliance, I believe you should be supporting the manufacturers that can show you this evidence, because they've invested in it. And as parts of the industry, you can encourage the right kind of behaviours from your suppliers. And looking at the test report, questioning it, doing that due diligence means that they're going to be more mindful. They're going to get support from the decision makers higher up the tree who approve to pay for this testing, if it shows that they're actually going to get supported in the market by doing so. So you can drive these behaviours, and I really think that that doesn't always happen. So on the data sheets, this isn't entirely comprehensive, but there's things that I certainly look for. I've read a lot of data sheets over the years, probably hundreds. Well, definitely more than hundreds, probably close to 1,000 different data sheets for different things. But make sure that the intended purpose and applications are really clear on that data sheet. Equally as important is the limitations that we really got to know. We can't assume anything, and if anything that you're relying on is not in the data sheet or varies from what's in the data sheet, you need to get that in writing, because what someone gave you as off-the-cuff advice and you're going to rely on it later, well, is that person there? Does that person remember? Was it the right person that got authorised it or checked it? You really do need to get that in writing. So you want to know what the service conditions are in terms of once the product's in use, how to store the product before it's being applied. All those things are really, really important and can affect the final performance. And you want to know, how do we check that the product's actually installed properly? What does the substrate need to look like? How do I prepare it? What if it's a liquid applied? When I put it on wet, the thickness will be usually different than when it's dry. So what are both of those? How can I make sure that I can test it and know what it should be? How long should I wait for recoats? Too little or too long can affect the final performance of the product. How should I mix it? What about the temperatures when I'm actually applying the product? What is the range there? If you don't see, and I've seen a lot of data sheets where they actually don't have any performance data written on it, not necessarily just for membranes, but generally speaking. The application instructions are not clear. And you see a lot of set and forget data sheets in the market where it was written 10, 15 years ago. Usually the suppliers that just have a couple of products that can do everything. They can do everything. Just ask us. They can. Trust me, you can. But when it comes to membranes, they don't have any references to standards. The data sheet's really old. Is it the most current? But is it a set and forget? There's definitely a lot of those out there. And especially with multinational companies, this data sheet may not have been written originally in Australia, and it may not have been updated when it comes to the local market. You know, they're all red flags that you should look out for and start to question and maybe get more information. So there's some limitations when it comes to testing, and I'm just going to run through a few of those, and this is more to give you food for thought. Change management is not really addressed in the standards when it comes to design and manufacturing. So a product design or a formulation can change. It could be for the better, it could be an improvement, but we may not know that. Our testing might have been done a couple of years ago. This doesn't get captured. We're using the information of the data sheet and the report and thinking it's what I'm actually buying today. Is it? Possibly. When it comes to manufacturing, you know, my first job I had after uni was working in a lab testing samples of coatings from a factory. And I know that if we changed equipment, if we made it in a different factory or, you know, upgraded something, this can all affect the final performance of the product. So these all changes can be happening behind the scenes. The product label looks the same, but you don't know. So there's nothing that in our current systems of evidence of suitability which actually picks any of these things up. Raw materials can also change. So raw materials can change source. They in fact have their own production sources as well, whether it's dug up out of the ground or manufactured in some way. Those can change. Often, especially for something you're manufacturing locally, you're testing, oh, the source of this raw material A, this one's cheaper, so let's put that in the formula, let's test it, do a test. Is it still going to perform the same? Yeah, we think so. But how thorough that process is of predicting change, all these things don't get picked up in our current standards. Long-term performance and durability. There is a reference, I think, in ACE 4654 Part 1 where it talks about suitability for service life, but that's it. That's it in the whole standard. It doesn't really explain what that means or how that's measured. Sorry, that's in 4654 Part 2. So we don't really consider the service life, the design life. We don't talk about maintenance and repair. So all these things are not captured in this data, and really they are important for the long term, what we expect, what our clients expect. VBA, which is the British scheme of testing products, it actually does have a service life component in their reports, and it'll give you an estimate of, you know, whether it's 5, 10, 35 years, it does actually provide information, some sort of assessment of the technology. We don't have that kind of information in our reports here. And similarly, I've seen Brands, which is a New Zealand building testing experts, laboratories. I've seen similar statements on some reports that they do as well. We don't have it defined. We don't know how to assess it. We sometimes throw the term about, but we really haven't resolved this as a local industry. And some of our standards, the standards that we have for waterproofing, there is nothing there for below ground. Now, I think there's some things in the works, but we still, to this day, anything below ground, once it's backfilled and buried, you can't get access to it anymore. To fix it is extremely expensive, yet we still, as an industry, don't have a standard for it. So thinking about the limitations is, I think, really important for informed decision making. I don't want to spend a lot of time in this slide because this is the old debate, liquid versus, you know, I didn't write liquid versus sheet, I wrote liquid and sheet, because the fact is there's some products that are more suited for some application than others. In fact, there was a LinkedIn post this week. I saw some remedial consultant actually proudly was saying, and on an exposed balcony, we would never use liquid membranes. We would only use sheet because we use the best. But the reality is there's no sheet that's going to be suitable for exposed traffic that any manufacturer, I think, would stand by. And in that case, that's probably one of the ones where you must use a liquid membrane. So it's interesting. Everyone thinks automatically go sheet, expensive, good, liquid, cheap, maybe okay. But it's not that simple. It's really not that simple. And what my basic drawing is trying to describe here too is, you know, the number of layers and the thicknesses, and trying to think about that. I actually think the liquid systems in some ways are harder to get right because you've got the recoat times, you've got multiple layers. There's actually a lot of labour involved with those multiple layers as well, but you know, I don't think that's always reflected in the costs that get quoted either. So moving on. So that's membranes. We've talked about the evidence of suitability of membranes. We're saying that 30% of the documentation that we have may be questionable, and that's the ones that are tested. And these are all products that are actually aimed at the professional market. This is not your DIY products or anything like that. So there's potentially a whole bunch more products out there that aren't tested, that aren't compliant. So in a way, that's kind of conservative in terms of numbers. But what about the components that we actually don't have a standard for? What do we do? Because there's nothing to look at. Well, I mean, what I'm trying to say with this selection of photo here is this person is head to toe in Louis Vuitton. The jacket matches the pants, matches the hat, matches the bag. Try and get your system from one source if you can, because at least you know it's compatible when it comes to solving a problem or even getting support before and after sales. It's going to go better, just built into that decision. So even though we've got the same materials, we can say certain material properties will apply, but just because this one's technology A and this one's technology A, it doesn't mean they're going to perform the same. It doesn't mean they're going to have exactly the same characteristics. So you can't assume that they're going to, you know, perform the same. So you need to actually go down and look at the evidence for that particular product. What is the performance? What is the history? Are there other projects? How well does the manufacturer know this product and how to apply it and how to problem solve? How well are they going to support you if something doesn't necessarily go to plan? You need to go to that extra level. And there's also overseas testing data available as well. There are standards around the world for these other types of components that we should be willing to look at if they're from a respected, known source like BBA, etc. So we need to make sure that we, especially where it's a critical thing, that we identify what those other components are. I kind of think in code mark, really, you should be not just writing the membrane, but having all of the other components that are compatible also listed on that report, but it isn't at this stage. But it should be a fairly simple thing to say, well, these are all the compatible primers. These are all the compatible bond breakers. Why don't we think about doing something like that? Now, so the other thing that we need to think about, as I've said, is compatibility, the performance. And I chose this example because it was visual. I don't know how well it will go. So water stops are something that are put into concrete joints, and they're there to stop water. They work on the principle of a tortuous path. So they're trying to provide a long pathway for the water to get through that joint. So you can imagine if it was flat, that's not as tortuous as something that has high ribs or many ribs. And so I often see on drawings, it'll just say PVC water stop. But within that, there can be a lot of different profiles, a lot of different performances, and where it's critical, I really do think that sometimes we need to go that extra step of saying exactly what is needed, or at least putting some kind of performance in there or some other requirement. And that's why I started the presentation talking about components, not just talking about membranes. I want to have a more holistic view of what goes into a successful outcome. So I mean, I've got a scientific background, so it's all to me about the evidence, not just about, you know, there's some, how well you get along with your supplier or how great they are, etc. Those things are good, they're important, but it's at the end of the day, you've got to have the right evidence of suitability, and on that note, when it comes to getting the most out of your supplier, I think at times people don't make enough opportunity getting most out of suppliers. As I said before, if you're asking for information that you want people to invest in, you need to build that relationship. You need to show that your decisions are being made based on that, and encouraging, finding the trusted suppliers in your market that you want to work with, that you trust their information, they're responsive to you before you buy the product, after you buy the product. And, I don't suggest you put all your eggs in one basket, but you can actually, change behaviours of suppliers. If they see there's an opportunity commercially, they will do that. If it means that the suppliers that have the best trained staff, they invest in training and time, reward those people by working with them. That's, going to really get better outcomes as an industry and at the end of the day for clients, for consumers. That's just one of the many pieces of the puzzle, but I do think at times influencing behaviours and getting the right outcomes can really make a difference. Now, I hope you didn't think I was going to go through all of these, because I'm not. You do get a copy. It is a big topic. I like this topic because it's something we can all learn every day, learn something new, no matter how small. And we've all got our part to play in that. Everyone in this room has their part to play in that process. So I'm just going to bring one more thing to your attention by going the right way, not the wrong way, because this is my last slide. There is a report, which you can see on the right there if you haven't seen it. It is a building defects library that the New South Wales Building Commission have put together. It has waterproofing in it, but not only waterproofing, there's other things as well. In their work over the past few years, particularly in Class 2, they've gone through and looked at the data of what are the most common types of defects and captured it in a single report. So they're just the waterproofing ones I've picked out. They are related to external and internal waterproofing. I definitely would encourage you to have a look at that report, seek it out, and learn from it, talk about it, share it, because at the end of the day, we just want those standards lifted. And I think that is my last slide. So yeah, I guess my message is think of waterproofing more than just membranes. Be more diligent about the evidence of compliance. Drive the right behaviours from the manufacturing industry by your own behaviours and your own conversations and your own relationships. And at the end of the day, let's have less defects, because there's certainly too many as it is. And that's it from me. Thank you.